Welcome back. This is part 3 and the final part for the Datasmith training, creating a DMO format translator for the nominals. We started off, or we finished the last segment where we created all the characteristics we needed for the X, which is the X nominal, the I vector, X upper, and X lower. And we started with the Y nominal. What I'll do is continue for all the Y characteristics and then for the Z characteristics. So we have a Y nominal that I created here. I have the instructions, and what I did was duplicate the X nominal. I changed the color and the association to Y nominal. And in the instructions, I made a change to the second one from looking at 1 comma to 2 commas. So search for the next character that is a comma 2 times. So in doing that, it moved over to the right once from the red marking of the X nominal, and I'm picking up now the Y nominal. So what I'm going to do is duplicate this and change this to the J vector. So modify, I will call this J vector. I'm going to change the color slightly and also the association to vector J nominal. And then also change how many commas it's looking in order to pick up the correct J value based on the file format. So for X, it was looking at the next character that's a comma 4 times after it finds cart, C-A-R-T. So one after that would be 5 times. So here I will say search for the next string cart, locate the next character, there's a comma 5 times. And we're doing it this way because if you remember, for every first instruction for all of the characteristics, the cursor always starts at the beginning of the section. So for this one, it's starting at the beginning. We're having it search for cart and then looking for the next comma 4 times. For the next one, it's doing the same thing. It's starting at the beginning. So again, we're going to have it look for cart, but this time look for the next comma 5 times before moving over once and marking the cell. Alright, so now I will duplicate this for the Y upper and Y lower tolerance. Y upper tolerance. And I'll change the color to something different. Go to associate. This will be Y. Spec limit. Relative. Bilateral. And this will be the upper, so upper. And again, that's going to be down beneath. So it might be a good time to show a few of the other shortcuts when it comes to editing the instructions. What I want to do, instead of changing each one of these, it would go faster if I deleted all these, copied what I did for the X upper tolerance, and then made one slight change. So to do that, first I can delete all of these instructions within this set. For any set that says instructions, if I click, hold down my left mouse button, and drag to the right, you're going to see kind of like a shadow version of instructions. If it's in this area and I let go, it will delete all the instructions at once. Now with those gone, I can go here to X upper tolerance, I can click here on instructions. If I right click, I can choose copy instructions. And then if I click back here to the Y upper tolerance, I can right click and choose paste instructions. And it will paste what I copied here to the instructions underneath. And of course, it'll duplicate the instructions, so it will overwrite what it's scanning. So then I have to make a change so that it picks up the correct value. So instead of looking for x-axis, I'll have it look for y-axis, which is underneath, found here. I do that. The rest of the instructions within the set will operate correctly to pick up that value for the y upper spec limit or upper tolerance. So now I'm going to duplicate this for the lower. Go to associate, change it to lower. And then here, instead of looking for the next comma 2 times, it's 1 behind. It's this value. So I will say 1 time, hit commit. And now I've adjusted this to pick up the Y lower spec limit. So the last thing to do is the same operations for the Z values. You can duplicate individual characteristics. Unfortunately, at this time, you can't select multiple and then duplicate. So I will simply duplicate this and repeat that process. So this will be Z nominal. We'll assign, say this color here. And then change the association. Z nominal. In this case, it's looking for cart. This will be found after the 3rd comma. That's the Z nominal. I will duplicate for the K vector. Change the association to K. And then here, locate the next character. There's a comma 3 times. If I look at what's going on with J, that's 5. It'll be 1 after that, so this should be 6. So I'll duplicate this. Or actually, it might, yeah, I'll duplicate this, go to modify, and then call this Z upper tolerance. Go to associate, this will be Z spec limit relative bilateral upper. So it's going to be this one. So again, what I can do, remove these instructions, copy this to here, change this to Z axis, picks up the right value. I'm going to duplicate this this Z lower tolerance, change the color and the association. There will be Z lower. This goes back 1 comma from the area, picks up the previous Z lower value. So with that being done, we're grabbing the X, Y, and Z nominal information from this file that's available. Now there might be cases for other files where you had other dimensions like position, or if you have a whole point, it might have a diameter nominal, or if you have a slot point length and width. In those particular cases, we can add definitions to this in order to pick up that information. So let's see if we have something like that in here. Yeah, for instance, see we have here a circle point. So this here says feature point, this says feature circle. There might be others that say feature slot, where it has more information about the particular point. Let's see here. I'm also noticing that for certain cases, everything's not found on the same line. For instance, here, if I go back up, that has IJK, but if I look down below, in this case, I have IJ, K is found on the line underneath. But the way my instructions are written, it's not accounting for the fact that this value can be on another line, and so that's not getting picked up. So that's another instance of seeing something in the format that we have to account or adjust for. So if that's the case, how can we edit our vectors to always pick up the right value, whether it's on the same line as the XYZ nominals or on the next line? Well, we can make some adjustments to the instructions. What I'm going to do, we still need to locate the next character, that's a comma. Move to, it says here, move to the next character, mark cell. I think what I'll do, instead of saying move to the next character, if we're here, we know that the next time it sees a number, it will be for the value that we want. So instead of move to the next character, maybe I can say locate the next character that is a number. One time, do not constrain to line. If I do that, it still finds the right number for this, but in cases where this might run off to another line, by saying locate the next character that is a number and do not constrain, it will continue to search off of this line onto the next one until it finds the next number. So that might help us to account for cases where all the vectors are not on the same line. So I made the adjustment for the I vector. I'm going to do it for the J vector. I'm going to say here, instead of move to the next character, locate the next character that is a number one time, do not constrain. And I'll do that for the K vector. So with that being done, if you notice before, this was not getting picked up on the second line, but now it is in these cases. So by making that adjustment, we've made the translator a bit more robust to handle situations where the vector values are on the same line and situations when they are not. So the next thing, there are cases like we see here where we have circle, where we have an extra value. This would be the diameter of the circle. We want to include that as well. So if we minimize those, what I'll do is create another nominal just for diameter. This will come in handy, or will be more relevant later on when we look at the inner workings of the CM4D Classic software, how we get to organize our features into different groups and turn on certain rules as to what type of dimensions we want to see for our features. The software categorizes our features in a particular way based on what nominal values we've loaded into the database for them. So if you want your feature to be known as a circle, there are certain nominals that you need to load: diameter, XYZ, and then something called normal or position as well being loaded for it. Actually, there is a table that shows this. If we go to the help file, we're going to go here to application, CM4D Classic. We will look at features. Click here on features, and it gives here a list of what are known as SMI types for the different features. We'll be getting more into this later, but we have surface features, hole, slot. There are what is known as constructed features, which are relationships between the features within the file, like midpoint, distance, range, plane, and polar. There's flush and gap features, XYZ, user, and non. And then we have a table here showing what nominal values or nominal dimensions we must have, which ones we can have, what we cannot have, and have at least one of for your feature to be considered in that particular category. So there's a surface category, a hole category, slot category, and many others like midpoint, distance, range. What we're interested here is probably the surface, the hole, and the slot. If you notice, for surface it says we need X, Y, Z, I, J, K. Those are essential or must have. It has to have at least a position or normal, so we'll need to declare one of those. That's going to be based off of the needs of the customer on the type of dimension that they need to see. The position dimension is a value that is like the 3D distance or deviation that accounts for the X, Y, and Z deviations measured against the measured versus the nominal. Normal is similar, but it's perpendicular to the surface or the vectors that are declared for that point, I, J, or K. So you have to have at least one of those, all of X, Y, Z, I, J, K. You cannot have any of these other dimensions declared as nominals for that feature. That's how a point gets put into this category. For hole, you need diameter, you need X, Y, Z, I, J, K, and you can have normal if you want. We don't need to have it, but you can have it. But you cannot have position for hole or slot. Okay, so yeah, this will come in handy later on, like I said, when we deal with CM4D Classic more so than Datasmith. But it's good to know so we can anticipate what types of groups your points will fall into later on. So what we're going to do here, we see that there's other cases outside of just XYZ, IJK. Sometimes it's declared circle. We have a diameter value at the end here. There's different ways of handling how to pick things up like this. There's some groups that want to duplicate this entire feature, and then they change the instructions in here to account for whether it says circle or point or slot or edge and so forth. Or you can have one generic feature, and within here you add in all the characteristics that could appear, and then you have those characteristics look to see if it is a circle or point or slot. So for this example, I think I'll go with just having one feature and then just adding in all the possible characteristics, but for those that could be optional or may not appear, I'll have them look within the feature for some key identifier so that the characteristic knows whether it should cancel or whether it should try to pick up a value. So in this case, I want diameter. This value only exists in a case where you have this declared as circle. It does not exist in other cases like point or edge or slot or others. So what I will do is probably duplicate one of the vectors. I'll change the name to diameter nominal. I will change the coloring. I'll be using this for now. And the association, it will be diameter nominal. So if I do that, you see that it changes the marking here. I only want this to function if that diameter exists, and that only exists when it says circle here. So what I have to do here where it says search for next string cart, I actually have to change this to look for this definition, circle. So what I'm going to do is insert an instruction above this, or maybe a few. And I'm going to say here, search for the next string feature / circle. I want it to find this piece of information because this tells me whether that diameter exists in the area or not. So if it finds this, the instructions will continue on. If it does not find this, then this whole thing halts and nothing happens with this characteristic. So if that's the case, I want it to look for this first. If it finds it, everything else executes, and if that's the case, what I'll do is get rid of this and this. I'll have search for next string feature circle. If it finds it, it continues. Search for cart, which it does. And this time, instead of looking for the next character that's a comma 6 times, I will say 7 times. Locate the next character that's a number, mark cell at current position. So by doing this, this characteristic will now only function if this instruction or any of these are true. So if this is true, search for the next string. If it can find this, the rest will follow and it will mark the dimension where it should be for a circle for diameter. So that's for the nominal. In this file, we don't have any tolerances, it seems, for the diameter. If we did, we would create upper and lower tolerance to pick that up as well. For now, I'm just marking this so I can have a diameter nominal in cases where it's a circle for later on. So we have that. Only other case I can think of is flush or gap. Not flush or gap, but slot, where you might have two diameters for your slot. In this case, we have feature arc. So that's a different case there. Feature edge. But for now, I think that might be good enough for this example. So again, it might be good to talk to the customer to see how much variation there is for their features and their output, what is possible for them to report out for that particular file format, what's consistent within it. All that information will help you build the most efficient translator for them and have the greatest chance of avoiding any errors or mistakes. The one last thing I want to do for this is make sure that this does not say circle for declaring a position nominal to account for surface points. So what I'm going to do is duplicate this X nominal. I'm going to call this position. Position nominal. I'm going to assign that a different color. For position nominal, the association is going to be position nominal. All right. For this case, there is no position nominal declared within the files themselves, but for that value, the position nominal is going to be 0, because a perfect measurement would mean 0 deviation and therefore 0 deviation in the position. So to declare what the value is instead of picking it up from the file, the first thing we'll do is make sure that we're in the proper type of feature. So I'm going to actually look for this location here and then make sure it's not circle. I want it to say point or edge. So to do that, that gives us another opportunity to show a different type of instruction. I'm going to do this. I'm going to insert instruction, and let's see, I'm going to say search for the next string. Feature and /. So that will put me here on this line in every case. It will put me at the front of feature, since I already know that it'll always say feature and then a / I know how many characters to go over, so I'll insert a new instruction. I'll say move to, instead of the next line, next character 5 times. That will put me here at this location. I know that I want this to say point or edge, but I can't look for both of them at the same time. But if I know that there's no other word that could appear besides point that has P, or another word that has E besides edge, what I could do is insert another instruction, and in this case I say must. There's an instruction called must where you can check for the value at a certain location. Must be, and there's string and there's something called one of. So if I say one of, this allows you to put in a series of characters, and instead of searching for that entire combination like a string, it will search for each character, and whichever one it finds first, that's what the statement will look for. So at that location I can say must be one of, and I'll say P E like this. Must be one of P E. So while it's here, it will look to see if the character to the right of it is a P or an E, which is what I want. If it is, then the rest of the instructions will continue. And what I want it to say after that case is simply another new instruction, which I'm going to put in here. Let's see, delete, delete, delete. Here I will say assign the string and then literally type in 0 and then hit commit. So this will make sure that it will find or check whether the feature it is in is a point feature or edge feature. And it will say assign the string. Okay, so again we have a case where we have the diameter defined for cases where you might have a hole, and position defined where it's looking for P or E as an indicator that it's in a feature that needs a position nominal. So if these instructions pass, then it will assign a string of 0, since that would be the position nominal anyway, and it's not found in the file. So that being said, one thing that we can do if we consider this to be a finished file, of course we want to save, but also we want to go to an option here called grid. So in this interface, if you look at the tabs at this location, you have one called grid. If we click on that, it will give us what the actual values are that we're picking up from the file for all of our characteristics. And they'll have the same color coding for the different columns as they do in the characteristic tree on the left. So in doing this, we can scan quickly the contents of the file and notice if there's anything off, strange, or suspicious about what we're picking up for the different values. If you don't like the layout of this, one thing that we can do is kind of change the ordering that we see here in the characteristics. For instance, I can go X nominal and then take the Y nominal, click and drag to the spot right below X nominal, and then do the Y for Z, click and drag to the spot below Y. Do same for the vectors, I, J, and then K vector, click, hold, drag, release. And then you have the X, upper, lower, Y upper lower, Z upper lower. And I notice here I do not have tolerance at the end. That's okay. This is just a name holder for us, an indicator, but it's good to be consistent. And then diameter, position nominal, you can move those if you want to as well. If I click back here on grid, it will order the columns according to what we ordered here in the tree. So now I see X, Y, Z, I, J, K vector, the upper and lower tolerances, and then I have the diameter nominal and position nominal here. So as you see, where there's position, there's no diameter, and where there's diameter, there's no position, because both are looking at the format based on the instructions we set up, so that their declaration is conditional based on whether the feature is a circle type or a point or edge type. Alright, so that's our data. We have a complete translator for the nominals, for the nominal information in this file. And if we wanted to load it, what we can do is manually output this to the database. Before we do that, I'm going to do one last check. There is a way to check the different associations that we assigned. And remember, those are very, very important because we don't want to assign the wrong data to the wrong data type. For instance, we have X, Y, and Z nominal. We have to make sure that the associations are correct for that, or otherwise we could be loading the wrong type of values to X, Y, and nominal positions in the database, which would basically jumble up the data and make the output not readable for the end user. So one way to check that is to go here to options. There's an options tab where you can go to view options, and here there's tree options on the left. These are the different columns that we can turn on within this left window pane. I'm going to turn on association, hit OK, and it will create a new column here called association, where it will tell you for each characteristic what the association is, which of course is what we assigned when we clicked on associations here. So we want to make sure the name that we called it, what we're picking up, corresponds to the proper association for each one of these. And this is one way that we can check quickly what those values are. So we have feature label, X, Y, Z nominal, I, J, K vector. We have upper, X lower, and that's associated with spec limit, relative bilateral upper, X spec limit relative bilateral lower. We should have the same for Y, Z, and then diameter nominal, position nominal. So given those things right now, this will be considered a complete translator. So if we want to upload this, the step for that would be to go to File and then Database Setup. And then we have a series of steps that we can follow. The first step is whatever configurement we have loaded. Right now it's called config A, where we've kept all our instructions. That can actually be changed if I click out, click here on config A. If I right click, I can choose modify config and change what this name is. I could call this DMO nominal format. There's other rules in here as well when it comes to the extensions, the file extensions you'll allow to be loaded within here. Any type of pre-processing, which are external files that can do some sort of modification or function to a file that we might normally not be able to load within Datasmith. Those are written internally by people in the development team for CM4D, or those who have any knowledge of Visual Basic or other languages to write these preprocessors for scanning text. And then there's a lot of options for types of files that we want to load in here, which these will be looked at later on. But right now I have nominal, DMO, nominal format. Change the name of that. If I go back to File, Database Setup, you see that it has a name change there as well. So that's the config. If I go to step 2, which is select data source, this allows you to connect to your CM4D database. So here I have what's known as a test database connected to the site. I'll choose this to load into. Step 3 is creating a new routine name, which in this case we don't need to do. It says if the routine label or code is defined in the file, it will be used regardless of the selection. So what we're doing is we're picking up the routine name that we're going to use from the file, which is this code here. That will be the ID under which all these checks will be seen or known. So supplying one here won't really matter for us. So we'll skip step 3. Step 4 is the permissions. This is about the type of data you will allow to be uploaded. So whenever we're uploading a new file or creating a new database record, typically everything will be checked because we want everything to be loaded in. This has create routine, create nominal, create sample, create update actuals, update routines, update nominals, update samples. We can have everything checked, but again, this is just a nominal file, so we don't have any sample data to upload or to create. That's fine. This just says that if you had that type of information, that will be allowed to be uploaded into the database. Step 5, output to database. We're going to click on this, and this will actually perform the uploading procedure of scanning this file and creating a data record in the CM4D database. So that's it. It took about 5 seconds on this system. I'll hit OK there and then exit. It automatically puts you onto this output summary page, which if you click on the right slider on the window, you can view a little summary report about what got loaded or what was successful. So file processed successfully. This routine, in this case it says updated because it existed in the database previous to the start of this training. But if it was brand new, it would say created. All of these would say created as well. And then at the end it has a report about routines updated, features updated, or created. So with that being said, that uploads this information into the database. This translator would now be considered a complete translator. So if I saved this and simply closed out of Datasmith entirely, let's say that there's a new file present that had different content but the same format. If I go back to start, open up Datasmith again, I can now go to File, Open, and open up the translator I created. And then click here on Add Files. I would go to where that file is present. And now that it's loaded in, it will scan the exact same way as any other file that shared that same format. And if I wanted to upload these nominals or update them, I would just need to do the procedure for going to database setup, going through these options again to output the information to the database. So again, once the instructions are written effectively for this file format, you really should not have to do this process again of going through and creating your instructions, creating your associations. This is really a one-time thing to create your initial translator that you will use over and over again to load in data that shares the same file format. Alright, so that ends the unit for creating DMO nominal file. Thank you for watching, and I will see you for the next module. Thank you.